So we're going to look at this through the model of split the middle term, which is tied to the algebra tiles, which is tied to the box method, but it's taking away those structures, and I'm going with a more complex problem here. But I'm going to start very similar to what I did with the others. I'm going to do this where I find A times C and I find B. Well, A is 3, C is negative 15, so that gives me negative 45 up here, and B is positive 4. Since this 45 is negative, I know one of my answers to here has to be positive and one has to be negative, because a positive times a negative gives me a negative. Only way I can get there. So I'm looking for two factors of negative 45 that will add to give me positive 4. Well, I'm going with 45 because it ends with a 5. I'm going with 5 times 9, and 9 minus 5 is 4. So my 9 would be positive and my 5 would be negative. Then using this, I'm going to write 3x squared plus 9x minus 5x minus 15. We call this split the middle term because that 4x is now becoming positive 9 minus 5, which equals to 4x. I'm splitting it into two numbers. This then allows me to go to the grouping method because I have 4 terms. What these two have in common, their greatest common factor, is a 3 and an x. And when I divide that out or factor it out, I get x plus 3. And that is, in my messy handwriting, a negative 5x minus 15. Oops. So I'm going to pull out a negative 5, and I get x plus 3. I need to learn to write where there's space. Negative 5, x plus 3. These are my common factors, which you could also talk about the distributive property. These two are getting distributed to these other two. And I get my x plus 3 because that's my GCF that I just factored out. And the other factor is 3x minus 5. Okay, so I'm going to start this one. One thing about this problem that's nice that I would want the kids to realize is everything's positive. So I'm not going to have to work with negatives at all. But my A times C is 12. 3 times 4 is 12. And 12 can be tricky because there's lots of factors to 12. And my B is 8, but they're all positive. Students will frequently see 3 and 4 for 12, but 2 and 6 they may not come up with initially. But my factors I do want are 6 and 2 because 6 plus 2 gives me 8. So I'm going to write this as 3x squared plus 6x plus 2x plus 4. You can actually put the 2x or the 6x in whichever order you want and you will get the same answer. But I'm going to group now these two and these two. What these two have in common is a 3x, and it's left me with x plus 2 when I factor that out, plus what these two have in common is 2, and I'm left with x plus 2. These two factors need to match. If they don't, there may be a mistake in there somewhere, but we're good so far. So that's my GCF, so it comes out x plus 2, and I'm left with 3x plus 2. And I can hear some of you in the background saying, but I don't think it works if she puts them in a different order. So let's do it. Let's go back to here, and I'm going to write it as 3x squared plus 2x plus 6x plus 4. So you can see that how I split that 8x here, that order does not really matter. So I'm going to group these two. I'm going to group these two. What these two have in common is x, and I'm left with 3x plus 2. What these two have in common is 2, and when I factor out the 2, I'm left with 3x plus 2. My common factor, 3x plus 2, and then x plus 2. And we can talk again about the commutative property, but these two factor forms do equal the same quadratic. Okay. So looking at this one, I'm going to start with my process that I know of. And 2 times 3, because up here I'm doing A times C, is 6. And B is going down here, which is 1. And it's going to talk about the fact that there's a 1 in front of that H, even though we're lazy mathematicians and we don't write it. And I want to look for something that multiplies to give me 6 and adds to give me 1. And my first instinct would probably be 2 and 3, where I have a negative 2, which would work, except for my 3 up here is positive. So these both have to be negatives, or they both have to be positives. And since that's positive, this one can't work. They can't both be negatives, and if they're both positives, when I add them, 2 plus 3 gives me 5 and doesn't give me 1, so this problem has to be prime.
That's why I really like to split the middle method with my students, is because it really does save them time on finding those prime
Right,
quadratics.
So I don't have to spend too much time guessing and checking.